Well, okay, what we're going to do is we're going to look at the Walker's Building Estimators Reference Book. This is going to be not too detailed because with the new format of the exam, you can't take this book in, but there are some things that you really need to know about the Walkers. The first thing that we're going to talk about, this is an interesting little concept on page 55. Now I'm on the 31st edition number 31. You may be if you're in a different edition, you know, all this information is going to be in every book that's been printed for the last several years, and probably into the future. But we're talking about the working drawing, so it'll be around page 55 or so. And there is a discussion under the working drawings in bold print. It says types of drawings. And it says most working drawings for building construction are based on orthographic projection. Okay, which is a parallel projection to a plane by lines perpendicular to the plane. Well, I don't know about you, but when I read this for the first time, it was like, what in the world are they talking about? It says in this way, all dimensions will be true if the plane, now this is where it gets interesting. If the plane is horizontal, the projection is a plan. If vertical, it is an elevation for the outside of the building or a sectional elevation through the building. Okay, so let's think about what that means. Okay, so first of all, you're going to see the term orthographic projection, and that you're going to say, aha, I've heard about this, orthographic projection. Okay, and then it says, if the plane is horizontal, the projection is a plan. So what I want you to do is I want you to think about a building, and I want you to take a slice out of that building horizontally. Okay, so this plane that is horizontal through a building, when you take that slice out and you look at it from the top, that's the plan view. Okay, that's all they're saying there. If the orthographic projection is horizontal, it's a plan. If that orthographic projection is vertical, you're looking at an elevation. All right, so it's a much simpler concept than what they're trying to explain there. And it's hard to explain in words, but if you're talking in normal conversation, it's a little bit easier. So try to get that in your head when they talk about orthographic projection. If it's a horizontal orthographic projection, you're looking at a plan view. If it's a vertical horizontal projection, it's going to be a vertical slice out of a building. It's just showing you the elevation, right? Yeah, you looked at enough drawings. That's starting to make sense to you then. Okay, so that's the orthographic projection. There are some symbols in here, and then starting on page
61.
Yeah, 61. Yeah, as you go through, the one that I want you to be familiar with is on page 68. It's a pipe. Well, let's see. Hold on, that's piping. It's electricals where I want you to, there's an electrical one. There's an outlet, general outlets. Here it is on page 62. I want you to find range. Okay, I want you to know that a range is a circle with 3 lines through it. Okay, and you can remember that however you want to. Ranges are usually 220. They're going to have 2 hots and a neutral. Okay, in addition to the ground. So there's going to be, 3 wires there. So anyway, but try to remember what that range looks like. Okay, keep that in mind. Another one I have highlighted is your flanged T down on page 68. Now, how you're supposed to remember these without the book, I have no idea, but just do the best you can. If you can remember that's a flanged T down, more power to you. Okay. On page, like I said, on page 68. I've seen that one before. These questions were not nearly as hard when you could bring the book in the exam with you, but for some reason, you can't bring the walkers in with you anymore. Okay. Which is a real a real challenge for you. Okay. So as we go through, I want you to see a few things. There's a concrete chapter. I don't think I have anything in concrete that you just have to know that generally concrete is, we're talking about concrete, we're talking about, we're talking in yards, usually 27 cubic foot to a cubic yard and what have you. Okay, let's see, where am I at next in the markers? 123. Let's back up just a little bit to page 123. Got some notes here I'm going to refer to. Page 123. So back up just a little bit. In this first chapter in the walkers, there's a lot of general information about before you get, actually start the construction process. And one of them is about scheduling. And you have, on page 121, you've got all these, you've got these different methods that are used for scheduling. And I want you to know about float time. And they have something called total float. Total float is on the top of page 124 in the 31st edition. And it's the amount of time an activity can be delayed without delaying the end of the project. Okay, so it's called float time. You might have a portion of the project that doesn't take as many days as another portion of the project happening at the same time being done by somebody else. And so the total float, you have some float time, and the total float, it says it's the amount of time activity can be delayed without delaying the end of the project. So you might want to consider that. Okay, here's a good one here on page 126. Now, this is a question that pops up from time to time, and it has to do with scheduling. And it says monitoring / updating in bold print. Once the project schedule is complete. I'm on page 126. It says monitoring, updating in bold print. Okay. Once the project schedule is completed and agreed on, this schedule becomes the baseline schedule, okay, against which all progress will be measured. So once you agree to that schedule, boom, that's your baseline. And as you move forward, obviously, going to be the rare project that's going to follow exactly to that schedule, but that's going to be your baseline. Everything you do, you're measuring against your baseline. So the next line says the baseline schedule is frozen and saved. All right, so just frozen and saved. That's what you gotta know there. The baseline schedule is frozen and saved. All right, here we go. As we go to, trying to think of the best place that I want to go to in this book next. Got me a few notes here that I want to, on page, let's go to page 514. Okay, this is where we talked about our different concrete blocks and how many blocks it would take. Now, see, you're not going to have access to this table unless they give you this table on the exam. Did they do that for you, Stephen? Did they give you any of these like charts and that kind of thing where you could read the information off the chart?
No, you didn't need to.
Didn't need to. Okay. Okay. Well, this is where they talk about the how many units, how many CMUs it's going to take to fill up a square foot. So if you look at that table at the top of the page and you look at the bottom 5 rows, these are all your standard type of CMU, which the face is 8 by 16, or what it says is 7 5/8 by 15 5/8. And that's just 3/8 inches shy of an 8 by 16 because you got to have a 3/8 inch bed joint. But if you look at the second to the right hand column, that's where you'll see the 112.5. So for every 100 square feet, you're going to need 112.5. That's where that number 1.125 comes from. That's so important. If you don't have that written down somewhere, you need to know 1.125 is how many CMUs it takes to fill up a square foot. So if you get the square foot of a wall, you want to multiply that by 1.125, and that's how many CMUs it takes to fill up a wall. Okay, very good. I do want you to find, there might be some information on wood trusses. Okay, there's different types of wood trusses, and those are on page 654 and 655. Now, these are hard to find. They're hard to know because there's so many types of trusses, and once again, you can't take this book in. But if you look at all of them, one of them I want you to try to commit to memory is the top left on page 654, which is what they call a king post truss. So what does that mean, king post? Okay, well, if you look at the diagram, you've got one vertical post right in the middle. So that's your king post. So try to remember what that is. That's a tough one to try to remember, but you might be able to do that. Okay. So I want to look at the roof. I want to look at the roof on page 788. So we're going to jump over to 788. Now, this is something that used to come up a lot on the exams. Okay. So on page 788 or thereabouts. Okay. So I'm in, once again, the 31st edition. On page 788, there's a diagram. This is a plan view of the roof. And it's got 68 by 62 and a half. All right. And then you've got this little cutout, which is 30 by 20. And if you've been around construction at all, or just using your common sense, you know that since the roof is sloped, excuse me, those flat area measurements are not accurate with regard to the actual number of squares or square footage of shingles you're going to need, or wood shakes, or whatever roofing material you're needing. So you can take the 68 by 62 and a half, okay, and you might just want to do that in your calculator real quick. I wouldn't pay attention to the calculations they have in the book because they'd make it more complicated than it has to be. So if we take the 68 and we multiply times 62.5, we're going to get 4250. Okay. Now we also have that little 30 by 20 section that is not in there. So we're going to subtract the 600, sap the 600, and then we're going to get 3650. So when we're looking at this area as a flat area, it's 3,650 square feet. But like I said, we know that we will not have enough material if we only buy 3,650 square feet. For one thing, there's going to be waste. For the other thing is, though, there's actually a slope to this roof. And so that's going to increase that area. All right. So what we do is we see that the roof is 5 and 12. We go up to our table. We want to disregard the pitch. The pitch is a separate type of a term. We're going to talk about rise and run. The rise and run is 5 and 12. So we drop down to 5 and 12. Next to 5 and 12, there's multiply flat area by 1.083. So we take our 3650 that we got, we multiply it times 1.083, and we get 3,952 square feet, 0.95 square feet. All right. So the other thing that, that might happen is they might say there's 10% waste, and you can multiply that times 1.1 if you want to. And then you're going to get, if there was 10% waste, then we're going to get 4348. Okay. And then with roofing, we should know that you generally discuss roofing in terms of squares, not square feet. Well, what is a square? A square is 100 square feet, 10 by 10. So you can divide that 4348 by 100. Okay, divide it by 100, and then we get 43 and change. And so the answer would be for that particular roof, you need 44 squares. Okay, so that's kind of what you want to know about a little bit about how to do a roof. Okay, and let's see, that's very important. I did want you to know about a what is called a flare. So I want you to go to page 1398, 1398. And you have that's at the bottom of the page 1398. Basically, it's like an area at the end of a driveway where you're pulling out of the driveway and it's got that little curved area. That's called a flare. And in order to figure out the air, usually on professional plans, there'll be a radius involved. And you take that radius, you square it, and then you multiply it times 0.215, and that's going to be the area of the flare. Okay, so 0.215 r squared is your formula, and we'll see that again. You'll see that again. Okay, so there you go. So that takes you through a lot of important stuff that you're going to need out of the Walker's Building Estimators reference book. Okay. All right, you good with that?
Yeah.
Okay, cool. All right, what I want to do is I want you to grab